I'm holding a Toyota Technical Service Bulletin, not something a YouTube channel wrote, not a forum post, an actual document issued by Toyota Motor Corporation, and it says something that directly contradicts what the sticker inside your oil cap probably tells you. And before anyone in the comments says this is overblown, I want to be clear. I'm not here to tell you Toyota makes bad engines. They don't. What I am here to tell you is that there's a specific set of conditions, a specific set of models, and a specific maintenance pattern that, when combined, appears to create problems that Toyota's own internal documentation has flagged. And most owners have no idea this exists, so let's get into it. Before we get into the why, let's talk about who this actually affects. Because if your car is on this list and you're running factory spec 0W-20, you need to hear this. We're primarily talking about vehicles built around Toyota's 2.5-liter dynamic force 4-cylinder engine and the 3.5-liter V6, both engines that showed up across a wide range of Toyota and Lexus products starting in the 2019 model year, specifically the RAV4 in both standard and prime configurations. The Camry, including the LE, SE, XSE, and XLE trims running the 2.5-liter, the Highlander, which moved to the 2.5-liter hybrid system in 2020, the Venza, which came back as a hybrid-only model in 2021 using that same engine, the Sienna, which also went hybrid-only and shares the powertrain, and certain Lexus ES250 and NX250 variants that share the dynamic force architecture. If you own any of these vehicles built between 2019 and 2024, and you've been following Toyota's recommended oil specification of 0W-20 with extended drain intervals, we're talking 10,000 miles or longer, you're in the population of owners this conversation is relevant to. Now, most people have no idea what a technical service bulletin actually is, and Toyota's service department is counting on that. Here's the distinction that matters. A recall means Toyota is legally obligated to fix something at no cost to you, and you probably got a letter in the mail. A TSB is different. A technical service bulletin is an internal service document issued to dealership technicians to help them diagnose and repair a specific problem they're seeing in the field. It's not a recall. It's not a public announcement. It gets filed in a database that your service advisor technically has access to, but that most customers never hear about, because there's no legal requirement to inform you. Think about that for a second. Toyota's own engineers identified a pattern, documented it, and distributed guidance to repair it. And the average owner driving one of these vehicles has no idea the document exists. TSBs become visible through the National Highway Traffic Safety Administration database, through ALLDATA, and through independent mechanics who subscribe to manufacturer service information. They're public record, but they're buried deep enough that most people never find them unless they're specifically looking. That's worth understanding before we go any further, because everything that follows is grounded in documented evidence. Not speculation, not forum rumors. Actual service documentation. Here's what's actually happening inside these engines, and once you understand it, the TSB starts making complete sense. The 2.5-liter dynamic force engine is genuinely impressive engineering. It runs an Atkinson combustion cycle. It has one of the highest thermal efficiency ratings of any internal combustion engine in production, and it was specifically designed to pair with hybrid drive systems. Toyota engineered this engine to extract maximum fuel efficiency, and part of that engineering involves extremely tight internal tolerances. Tight tolerances are generally a good thing. They mean less friction, better combustion sealing, more efficient power transfer. But tight tolerances also mean the oil film doing the work between metal surfaces has very little margin for error. Now let's talk about viscosity, and I'll keep this simple. The 0W part of 0W-20 refers to how the oil flows when the engine is cold. The 20 refers to the oil's thickness, its resistance to flow at full operating temperature. A 0W-20 is intentionally thin at operating temperature. The thinness is the point. It flows easily, reduces pumping losses, and contributes to the fuel economy numbers Toyota advertises. Here's the thing though. Thin oil, by definition, provides a thinner protective film between moving metal parts. In normal operating conditions, that's fine. The film strength of a quality 0W-20 is adequate for what the engine asks of it, but normal operating conditions is doing a lot of heavy lifting in that sentence. The dynamic force engine uses direct injection. Fuel is sprayed directly into the combustion chamber rather than into the intake port. Direct injection is more efficient, but it has a known side effect: fuel dilution. Small amounts of unburned fuel wash past the piston rings and end up in the oil. This is normal and documented across all direct injection engines. It's not unique to Toyota. But here's where the dynamic force application gets specific. The compression ratio on the 2.5-liter runs exceptionally high for a gasoline engine, around 14:1 in Atkinson mode. High compression means higher combustion temperatures, Higher temperatures accelerate oil oxidation and speed up viscosity breakdown. The 0W-20 that went into your engine at the beginning of a 10,000 mile drain interval is measurably thinner and more compromised. By the end of that interval, then a 5W-30 would be under the same conditions. Add to that the hybrid operation pattern. Hybrid engines run through repeated cold start and stop cycles. Every time that engine fires up cold from an electric-only stop, it's starting from ambient temperature with oil that has drained off the cylinder walls. Cold starts are when the majority of engine wear occurs, not during sustained highway driving. The more cold start cycles you accumulate, the more the cumulative effect of that thinner oil becomes a factor. Now, the naturally aspirated 2.5 is one conversation, but if you're in the RAV4 Prime, the Venza Hybrid, or anything with the Turbo 4, that's a completely different level of concern. The RAV4 Prime adds a turbocharger to the 2.5 liter in certain configurations, and turbo applications create a fundamentally more demanding environment for engine oil. Turbocharger bearings spin at up to 200,000 RPM. They're lubricated exclusively by engine oil. When you shut a turbocharged engine down, those bearings are still spinning as the turbo spools down, and if the oil feeding them has degraded significantly through a long drain interval, that bearing clearance becomes a problem. Turbo oil coking is a real failure mode. When degraded, heat-soaked oil sits in the turbo oil feed lines after shutdown. It can bake into a varnish that progressively restricts flow. The TSB-related complaints from turbocharged variants document exactly this pattern. Elevated wear metals in oil samples, reports of turbo bearing noise at startup, and in more advanced cases, reduced turbo response that owners initially attribute to normal behavior. If you're in a turbocharged application and you're running 0W-20 on a 10,000 mile interval, you're stacking risk factors. That's not me being alarmist, that's physics. Lab analysis from extended drain oil samples pulled from these specific engines tells a consistent story, and it lines up with what the TSB is flagging. Independent oil analysis labs and Blackstone Laboratories is probably the most referenced in the enthusiast community, publish anonymized fleet data that shows wear metal trends by engine type. What the data from 2.5 liter dynamic force samples submitted by owners shows is elevated aluminum and iron wear metals in samples drained at or beyond the 10,000 mile mark. Aluminum wear in particular is significant because the dynamic force uses an aluminum block with steel cylinder liners, and finding elevated aluminum in the oil suggests wear at bearing surfaces and oil contact aluminum components that shouldn't be contributing measurably to a healthy engine's wear profile. Now, wear metals alone don't tell you the engine is failing. Some wear is normal. What the data shows is a pattern. Samples from engines maintained at 5,000 mile intervals with the same 0W-20 oil show wear metal levels that are proportionally lower than extended interval samples from equivalent mileage engines. That gap is larger than you'd expect if the only variable was drain interval. If you could pull apart a high mileage dynamic force engine that was run on extended 0W-20 intervals versus one maintained on shorter cycles, the difference becomes visible. Carbon deposits on piston ring lands, varnish buildup on oil control rings, which affects their ability to scrape oil cleanly off the cylinder wall. In the worst cases, a residue behind the piston rings that can contribute to ring sticking, which affects compression, increases blow-by, and accelerates that fuel dilution cycle we talked about earlier. This is the physical mechanism the TSB documentation points toward, not catastrophic failure in most cases, gradual degradation that doesn't announce itself until it's expensive. To be fair to Toyota, in this matters, they have a real engineering reason for speccing 0W-20 in the first place, and it's not just about cutting corners. The fuel economy case for 0W-20 is legitimate. The EPA fuel economy figures that Toyota advertises, and that influence purchasing decisions for millions of buyers are achieved with 0W-20. Moving to a thicker oil creates measurable, if modest, fuel economy penalties. In a hybrid powertrain optimized down to fractions of a percentage point of efficiency, that matters to Toyota's engineers and to the regulatory framework they're designing within. There's also a genuine cold start argument. The 0W cold flow characteristic of WW-20 means the oil reaches critical engine surfaces faster from a cold start than a heavier viscosity oil would. In cold climates particularly, that fast cold flow can reduce cold start wear, which is exactly the type of wear the hybrid's start-stop cycle creates most of. Toyota's position, if they were sitting across the table from you, would be that 0W-20 meeting the ILSAC's GF6 specification is formulated to handle these engines. Their testing validated it for the drain intervals they recommend. And for many owners in many conditions, that's probably true. But here's what the Technical Service Bulletin issued in the context of these complaints reveals. The field data, the real-world usage data from how actual owners drive and maintain these vehicles, showed enough of a pattern that Toyota's own engineers felt the need to document it and provide guidance to technicians. That gap between engineered expectation and observed field behavior is exactly what TSBs exist to address. So here's where I stop giving you information and start giving you a decision framework, because the answer genuinely depends on your specific situation. If you're driving a 2019 to 2024 RAV4 Prime, RAV4 with a turbocharged variant, or the Sienna Hybrid with under 50,000 miles, and you're still under Toyota's powertrain warranty, you're in a delicate position. Changing from the factory-specified 0W-20 without documented guidance could theoretically create a warranty dispute if a related failure occurs. And what you can do without touching the viscosity question is cut your drain interval. Go to 5,000 miles or 6 months, whichever comes first. That alone removes the extended interval factor, which is likely the larger of the two risk contributors. If you're in any of the listed vehicles between 50,000 and 100,000 miles and your warranty has lapsed, the TSB pattern and lab data together suggest that moving to a 0W-20 full synthetic meeting Toyota's specifications, specifically looking for the Toyota Genuine Motor Oil designation, or an equivalent meeting ILSAC GF6A at 5W-30, is a meaningful change. The slight fuel economy difference is real but small. The added film thickness under sustained thermal load is also real, and at this mileage range, the cumulative protection advantage starts to outweigh the efficiency penalty. If you're over 100,000 miles on extended 0W-20 intervals, and you haven't had an oil analysis done, that's the first move before anything else. A $30 Blackstone Labs analysis of your current oil will tell you more about your actual engine condition than any general recommendation I can give you. If your wear metals are clean, you've likely been fortunate with your driving patterns. If they're elevated, you now know what you're dealing with before it becomes audible. If you're in a naturally aspirated Camry or standard RAV4 doing primarily highway miles in a moderate climate, the urgency is lower. The dynamic force engine in that application, with fresh 0W-20 and conservative drain intervals, is working within its design parameters more reliably. You're not in the clear, but you're not in the high-risk group either. For anyone in a cold climate, and I mean consistently sub-freezing winter temperatures, don't rush to move away from 0W-20 as your year-round oil without understanding the cold start trade-off. A 5W-30 behaves differently at minus 20 degrees than a 0W-20 does. And if you're in Minnesota or Alberta, that cold flow characteristic genuinely matters for the hybrid's repeated cold start cycle. Before you do anything else, there's a 90-second check you can do in your driveway right now that will tell you more than anything I've said so far. Pull your dipstick. Wipe it clean, reinsert it fully, pull it again, and look at the oil on the end under good light. Fresh oil is a clear amber. Oil that's starting to degrade goes darker, toward brown. Oil that's significantly broken down looks black, and may have a slightly gritty texture when you rub it between two fingers. If your oil smells faintly of fuel, and you'll know. If it does, that's the direct injection fuel dilution we talked about, and it's telling you the oil is compromised. If you're at or near your drain interval and the dipstick tells that story, don't wait. Change it now and document what comes out. That observation alone gives you a data point for your specific engine. If your car made that list and you've been doing exactly what the manual says, 0W-20 10,000 mile intervals, drop a comment below and tell me what mileage you're at and whether you've noticed anything. I'm genuinely curious what the distribution looks like across people watching this, because the sample size in the comments section of a video like this is actually meaningful data. And if you know someone driving one of these vehicles who has no idea this TSB exists, and statistically most of them don't, send this to them. Not to scare them, but because a $30 oil analysis or a slightly shorter drain interval is a lot cheaper than the conversation nobody wants to have with a service advisor at 140,000 miles. If this kind of deep dive into what the documents actually say is useful to you, subscribe. There are more of these coming, not rumors, not forum speculation, actual service documentation that most owners never see translated into plain language. Your engine's already running. Make sure what's protecting it is actually doing the job.